Hi everyone, in this video I will show you how to interconvert between mass, moles, and the number of particles. I made this diagram which I think will be pretty helpful when solving these type of problems. So the way you read it is going from left to right, that's why the arrow is going to the right. Everything on the left side has to do with division, and then everything on the right side has to do with multiplication. So for example, if you want to convert from mass to moles, you would divide mass by the molar mass to get moles. If you want to convert moles to mass, you would multiply moles by the molar mass to get the mass. The same idea applies to when you're trying to get particles, interconverting between particles and moles. So if you want to get moles, you would divide the number of particles by Avogadro's number to get moles, and if we want to get particles, you would multiply Avogadro's number by the moles to get the particles. So let's see this diagram in action by solving this problem. We're asked how many moles of carbon are present in 30 grams of carbon. So what are we doing? We are interconverting between moles and grams, and to do this, we need a conversion factor. And the only conversion factor that incorporates moles and grams is the molar mass. So what is the molar mass? If you look at your periodic table, you see that carbon has an atomic number of 6 and an atomic mass of 12. That's what it should look like on the periodic table. So what does this mean? 12 is the molar mass. This means that for every 1 mole of carbon, one mole of carbon has 12 grams, which can be written as 12 grams per mole. So repeating that, there's 12 grams for every 1 mole of carbon. So let's start with what we're given. We have 30 grams of carbon. So let's write down 30 grams of carbon. C stands for carbon. Because the grams of carbon is on the top, or the numerator, we want to cancel that unit out by having grams of carbon on the bottom. So we see the conversion factor is 12 grams per mole. We can write 12 in the denominator and 1 mole of carbon in the numerator. This way, the grams of carbon units cancel. And if we do 30 divided by 12, we get 2.5. And since the grams of carbon already canceled, we have 1 mole of carbon, so we're left with the units of mole carbon. So for every 30 grams of carbon, that is the equivalent of 2.5 moles of carbon. Going back to this diagram, we were converting grams, which is the mass, into moles. So we would be going from this box to that box. And to check our work, we can we see that we were supposed to divide the mass by the molar mass to get moles. Although this seems like we're multiplying it, it's actually the same thing as dividing it. So multiplying 30 grams of carbon by 1 over 12 grams of carbon per 1 mole is the same thing as dividing 30 grams by the molar mass, which is 12 grams per mole. Both of these turn out to be 2.5 moles of carbon. So now let's try to take this one step further. How many particles are in blank moles of carbon? So in the previous question, we found that there are 2.5 moles of carbon, and we're just going to transfer that over to the next question. So what's the conversion factor when we're converting between particles and moles? You should have said something like Avogadro's number, which is the equivalent of 6.022 times 10 to the 23rd. The units are particles per mole. So this is just a constant, just similar to how 1 dozen is equal to 12. 1 mole is equal to 6.022 times 10 to the 23rd particles. All right, so we start with what we already have, which is 2.5 moles of carbon. We have the conversion factor of 6.022 times 10 to the 23rd. So we want to eliminate this mole unit and have mole on the bottom. So this, with this, we can put 6.022 times 10 to the 23rd particles in the numerator and 1 mole in the denominator. This is the same thing as this, because for every 1 mole we have 6.022 times 10 to the 23rd, sorry about that, particles. Plug that into the calculator and we get 1.5055 times 10 to the 24th. And since the mole units cancel in the numerator and denominator, we're just left with particles. So we have 1.5055 times 10 to the 24th particles of carbon. You could round this to 1.51 times 10 to the 24 particles. This would have to depend on what your professor wants when you solve this problem. The most important things when converting between mass, moles, and particles are what conversion factors you want to use. So when you're converting between mass and moles, let's see. Moles, the conversion factor is the molar mass. And you're converting between moles and particles. The conversion factor is Avogadro's number, which is 6.022, which is always 6.022 times 10 to the 23rd particles per mole. Just remember this. This is, there you go. All right, now you try practicing converting back to the grams of carbon. So try working backwards by converting the number of particles into the number of moles back into grams. So pretty much particles to moles to mass in grams. At each of these arrows or steps, there is a conversion factor that you will be using. Try using this. If you need some extra help, try using this diagram to solve it. You should get the exact same numbers, the exact same values as what you did going forwards as you do going backwards.